So data engineering, I think the fact you guys are here tonight already shows that, data engineering is definitely, generating a lot of buzz nowadays. And it's been around for so many years, but people usually don't call, like, right? The job title may not be data engineers. It could be ETL specialist. It could be data warehousing engineer. So it's more specific. But now this data engineering title is obviously, just like data scientist. It sounds pretty cool, and it means you can do a lot of different things with data. And it is, I think part of the engineering discipline, but I think the whole engineering discipline is also starting to merge in the data field, and it's getting more and more specialized as well. So let's talk about that. The First of all, I think data engineers need to know many different things, but when you actually get hired by a company, you might be focusing on one aspect of it. At least you're not going to be doing 10 different things all at the same time. You might be working on a data warehousing or data ingestion project to help the company ingest, SaaS data sources, right, into your data lake or the data warehouse. So you might be working, with some tools like Airbyte, or you could be working with Azure Data Factory for data ingestion. And after that, the data is ingested, you might be moving on to build data pipelines to do data cleansing and data integration. If your company has real-time streaming data, then you might be working on a project that requires knowledge of Spark streaming and Kafka. But in general, I think a data engineer do need to know a lot of different things. So it overlaps with data science, software engineering, and a little bit DevOps as well. So let me explain that to you. First of all, I think the overlap between data engineer and data science is pretty obvious. They use very similar tools. Data engineers need to be able to code in SQL and Python, and data scientists nowadays, I think Python is the most popular data science programming language as well. And especially with packages such as Pandas and PySpark, and SQL as well for data scientists. Data engineers need to be able to manipulate data, do data cleaning, join tables, right? Need to be able to do data aggregations and sometimes doing a little bit reporting as well. That's what data scientists do, or data analytics professionals, work on this as well. But of course, the data science or data scientists focus will be more on the advanced analytics side. But data scientists usually all, are required to be able to write SQL queries to, retrieve data themselves and build the feature tables. But when they deploy that to production, and they may get help from data engineers to automate data pipelines or machine learning pipelines. And in some companies, it might be the machine learning engineer. Data engineering overlaps with DevOps engineering as well, mainly because a lot of the data engineering, the scripting, right, the SQL scripts or the Python script you write needs to go into production as well. So I think this engineering field, data engineering, is starting to more and more adopting, continuous integration, working with, GitHub, doing a lot of the unit testing. So definitely, I think data engineers need to have basic knowledge of CI/CD, understand how to work with Docker containers and, even Kubernetes, even though data engineers don't really need to be the person, DevOps person who's setting up the infrastructure, but data engineers might be the users of, a Kubernetes cluster running Airflow pipelines. So knowing some, Docker containers, CI/CD will definitely help data engineers to do a better job and help them automate a lot of the, the boring, workflow. And of course, data engineering overlaps with software engineering. So data engineers will need to write decent code as well. A lot of data engineers actually focus more on SQL, but there are also data engineers that, build applications as well. So data pipelines is some kind of data product data engineers will need to build and maintain. So they will need to be able to write decent code. So that's the overlap between data engineering and software engineering. But what do they do? So you may have attended the previous session we did. In case you haven't, I'm going to spend 5 to 10 minutes to explain you know, the responsibilities of different kinds of data roles. Okay. So this is, this diagram shows you a very high level, workflow and also the deliverables of different kind of data jobs. I would say, for machine learning engineers, they are more on application side. So the work they produce might be an API that can be used by, the web application team or the dev team. And BI engineers or data analysts, they are building products as well, but these are data products. So consider a dashboard as a data product that you need to share with executives, or data engineers are building like a data pipeline, and that needs to be automated. If something fails, you need to have proper monitoring, and you need to have notification. And let's say one of the function was created incorrectly, and it's causing your pipeline to fail. And once you discover that issue, you probably want to fix that, so you need to do the backfilling as well. So working with, tools such as, Apache Airflow allows you to do, the backfilling as well. So think of the data pipeline as a data product the data engineers need to build and maintain as well. Okay, so let's start from the bottom. So a typical data projects will start from, business definition. And of course, once you understand what the business is trying to achieve, the first question a product manager will have is, do we have the data? So you have to do the data sourcing, right? Figuring out where data comes from for this particular project, whether it's building a machine learning project or building a data warehouse. You need to identify the data sources that you need to work with. This is typically a data engineer's responsibility, right? Of course, on a typical project, there will be project managers. Sometimes there might be product manager. You'll be working with different line of businesses as well, trying to understand not only where data come from, because recently, this data warehouse project we've been working on, and the client doesn't really have proper documentation, and the business teams, they are not very technical, which means literally there's no one there to help you, right? And that's probably why they need our help. And so we have to do a lot of reverse engineering. And throughout the whole process, we're trying to learn, for example, the accounting process, right? My personal background, I'm more on a marketing and business intelligence side, right? So building machine learning models and building pipelines and stuff like that. Now, the client wanted to build this massive, data warehouse project, and accounting data, finance data is part of it. So they use Microsoft Business Central. And again, data is very messy, not well documented. So working with, so first of all, we got really overwhelmed because when we got access to the raw database, right? It's SQL Server, and just for one line of business, 20,000 tables. And we were like, how are we going to get this done? So it's really overwhelming. But and then when you talk to the business, right? The business, they understand like what they need, but they have no clue about, oh, this application I'm using, there are actually 20,000 tables behind the scene. But you need to have some strategies, right? And then when you start to do some kind of data, very simple queries, just count the number of rows, and you realize that actually 18,000 of those tables are like empty, which means they don't really use the full functionalities of Business Central, which is the ERP system, right? So we're left with 2,000 tables now. But which tables are more important, right? And it turns out that accounting, general ledger, these are really complicated stuff. And when you create a sales invoice, right, the application behind the scenes is going to update like at least 7 to 8 different tables. So we have to run a lot of queries and do a lot of guesswork and also do a lot of research. My point here is that sometimes even understanding the raw data and is very challenging, which means data engineers also need to understand business process. Like if you don't really understand, accounting process work, like you don't need to be an accountant, right? You don't need to like have a certificate, like become like CPA, but you do need to understand like the data flow behind the scene. So problem solving skills is really important. Like you have to run a lot of queries. just trying to understand how these tables are related to each other. And then you have to verify your instinct with the business and check if that's the right way to do things. And a lot of times you don't get help from the business, and you have to get on a call with some, experts who's worked in this field. But anyways, that's what data engineers need to do. Since sometimes people say data engineers don't really need to touch the business side, but understanding the source systems is really important. So you do need to understand, for example, how the business process in general works. And most importantly, it's, you need to understand how data is generated in this business you're working for, right? Because every part of, your applications are going to generate data. Where is the data written to? What kind of process, how does the process look like? It's all going to help a lot if you understand the business process better, okay? Yeah, long story short, data engineers need to ingest source data, because the source data might be coming from different kind of databases. I think for this client we're working with, they use SQL Server, they use MySQL, but there are also a lot of data coming from the SaaS software, like the marketing tools, their ERP tools, Business Central, and things like that. So that means you need to understand how to work with different kind of data ingestion connectors, connecting to different source systems, ingest the data, and data needs to be stored somewhere. So we sort of took a data lake approach, data lake and data warehouse. So when we ingest data into the lake, there's some very sensitive raw data that we need to mask and encrypt as well. And after that, we'll write the data integration and data cleaning and whatever data pipelines. So that's a lot of SQL scripting and some PySpark jobs to process the data. And then the data will be prepared for analytics purpose, right? So throughout the whole process, you need to do the data modeling, the design, trying to map out, the entity relationship and decide how you want to build everything. And it's challenging, and sometimes you have, different kind of ideas, but also based on because you're working on a project, so there's always time constraint as well. So you need to make sure that you find the best solution within some sort of time constraint. And the final product will be, a dimensional model loaded into the warehouse and build a bunch of, white tables that the clients can be used to do their reporting and business intelligence, right? So, but there are a lot of other things involved. I'll show you the workflow. So to help you understand that it's not just writing the code, right? So you have to do the UAT, work with the business to create the reports, and data is often messy, and sometimes you just have no clue how to clean it because you don't really understand the business rules. So anyways, a lot of communications is required. Definitely need a project manager as well. But that's what the data engineers typically focus on, right? In this orange box, that's pretty much what the data engineer will do for one type of projects. It's not always the case. Like sometimes data engineers work on something else, but I would say this is is probably 80% of the time. That's what the data engineers will be doing, right? Moving data from source, right, to staging and to a warehouse or a data lake somewhere. The work you do is directly impacting the quality of the analytics work. So I think a lot of companies start to realize how important data engineers are. You can't really just have data scientists, right, building models. What if the data is not accurate? And you also want the data to be consistent, right? So that's what the data engineers do. After the analytics data has been prepared, the BI engineers or data analysts will be focusing more on the data analytics side. So they'll be writing a lot of queries, building reports, a lot of ad hoc analysis, and of course, building dashboards. And there's a new trendy job title, which is data or BI engineer. I think that overlaps more with data engineering, which means if you're really good at SQL and coupled with some kind of powerful data warehousing tools such as Snowflake and also DBT, you can actually do a lot of the data engineering work as a BI engineer. So that's kind of similar to data engineering, but I think the BI engineer also need to build dashboards as well, do actual like analytics. In the green box here, we will see what the data scientists will need to work on. So they will take the data prepared by data engineers and do more advanced analytics, building machine learning models. They need to generate predictions. But I think data scientists focus more on the data visualization, analytics, and of course, machine learning. When it comes to automation and also generating prediction, you definitely don't want to do that manually. So you need to automate that. It's usually automated by either data engineers or machine learning engineers. Sometimes the machine learning models, data scientists or machine learning engineers built can be deployed, as a prediction service, which means you're building some sort of API endpoints, which means it can be leveraged by your live applications. For example, if you go to Netflix, you're getting some sort of personalized recommendations, movie recommendations, and it works in real time. Even though the models can be trained right offline to generate the latent factors, and it's pretty massive matrix that you can store offline, but there's online prediction part as well, and these microservice endpoints will be very useful, which means machine learning engineers who help the data scientists deploy models also need to understand how to build applications so that they work with the software team directly. But the responsibility of maintaining the endpoints, right? All the machine learning magic happens on the machine learning team side, like data science side. It's not really maintained by the software teams anymore. So you sort of separate, the concerns and the responsibilities in this way. There's good or bad. It's getting more and more popular, but for some businesses, if latency is really important concern, and Microsoft may not work, in the best way. So they probably still need to convert the models to C++ or Java code. And that probably requires machine learning engineer or software engineers. This is a quick introduction to, the deliverables for different type of data jobs. And hopefully that helps you understand, the differences, even though, they might be using Python, this exactly the same tool, but they're using that for different purposes. And that's the difference, among these different data roles. But it's not set in stone. Data engineers sometimes build APIs as well. Data scientists sometimes deploy models as well. Data analysts sometimes, build automated machine learning model, and even building, machine learning models using Scikit-learn and TensorFlow. It all depends on what your company needs and how big the team, how mature the team is. And these roles are more divided, right, when the team becomes bigger and more sophisticated. But if you join a startup, you're the first, first 5, data person on the team, you're probably going to do a lot of different things, wearing multiple hats. So be prepared for that. In terms of the skill sets, the BI analysts and data scientists, they definitely focus more on the, analytics side. So they work more closely with the business, wanting to communicate with the business, do presentations. But before they do that, they have to do data analysis, machine learning. Data scientists probably need to know a lot more about math. But data analysts will also need to know math and basic statistics so they can interpret those numbers correctly, and sometimes need to do some statistical testing as well. These two roles both need to know how to work with a database, right? And I call that data store here because it could be a relational database, or it could be data stored in Amazon S3 in a blob storage. So the data analysts and data scientists will need to know how to write queries to read those blob files. Okay, and data engineers, ML engineers, they definitely will need to do more programming, and they work with the infrastructure as well, even though they are not platform engineers. Understanding containers, working with AWS EC2 instances, sometimes like launching Spark clusters. These are the requirements for a data engineer in production. this is probably done by the DevOps or platform engineering team. But at least doing on the dev side and doing POCs, I think data engineers would expect to just roll up your sleeves and just set everything up yourself, because the company or startup may not have the resource to, like, a dedicated platform team to help you to build everything. So you'll need to be prepared to do that. Data engineers don't really, work with math, right? They don't really need to do machine learning, but I think understanding the overall workflow will be helpful. Because in some companies, data engineers will need to be helping with, building the pipelines or doing all the automation. Machine learning engineers will definitely need to know, understand math and machine learning. It's a mixed role as well. Machine learning engineers need to know data science, machine learning, deep learning, but also be really good at software engineering and know how to build data pipelines as well. But these 4 data roles look quite different from, software engineering and DevOps, which doesn't involve that much with data. So yeah, I won't spend too much time on DevOps and software engineering today. There are different types of data engineers. I have 4 different types here, but there could definitely be more. Or there are also data engineers who work on a little bit of everything. But in general, I would say ETL engineers or ELT. So there are a lot of companies out there that needs business intelligence, like more than they need data science. These could be traditional businesses, new startups. They don't even have, it could be a traditional business that has a lot of data already, but their technology stack stacks are pretty outdated. It could be a startup that hasn't really collected enough data yet for machine learning. So machine learning may not make sense. It's on a roadmap. But at this point, every business department will want some kind of data and insight. So that already requires data engineering effort, right? So you have to do data ingestion properly, because when the software team builds the software, they definitely wanted to set up databases and stuff like that, and to writing all the application data to the databases. Those are production database and operational database. Data engineers don't need to worry about them, but data engineers will need to know how to move those data from the operational data store into the data warehouse. And that's already a pretty complex, problem. And then because you don't want to run your business intelligence application directly on your production database, right? So it's going to impact production performance. So that's why you need to move a copy of your data somewhere else, whether it's on a daily basis or even just doing real-time change data capture, which is what we're going to teach in a boot camp. But that's what the data ETL engineer, ELT engineers will do, working with different data sources, ingest them into the warehouse. And in order to do that, then you have to create the staging environment, data models, and things like that. So that's one type of data engineer. Like that might be 100% of your focus if that's what you're hired for. These are data engineers, and I think many companies already have this kind of roles, right? But the changes we've observed in the last few years is that a lot of companies are migrating to the cloud. They would like to work with modern databases, or data warehouse technology such as Microsoft Azure Synapse, Redshift, or Snowflake, and that sort of involves a little bit different workflow. Because companies used to work with IBM technology, using data stage, like especially the banks, working with Informatica, and these are or the SQL Server, tools. But these are dedicated ETL tools, right? That helps company do data extraction, loading, transformation. But there are a lot of open source projects out there nowadays that can do even better jobs, right? And they're more adaptive and so that's why even the traditional data engineers and data warehouse engineers will need to adapt. So they need to learn open source. The new company you join next might be using Apache Spark because their data volume is really big. They might be using Snowflake, and even Snowflake is now supporting something similar to Apache Spark, which is a competitor to Databricks, right? So there are a bunch of new things you need to learn. Most of the ETL specialists used to be really good at scripting and writing SQL, understanding data modeling, but they sort of need to pick up Python and work with open source tools. But I think the fundamentals and principles will be very similar. It's really just about learning some of new tools for this kind of data experts. And the second type of data engineers are what we call data savvy software engineers. So from time to time, like software engineers need to wear multiple hats, right? They might be the person who's setting up databases. It's usually the software engineers who's writing the applications to send data to a database, right? Because every application you build gotta have some kind of database in the back end. But data engineers wanted to sometimes do data ingestion as well, and building data-driven application that requires software engineering as well. So these are what we call data savvy software engineers. They might be working with streaming applications. They'll be doing some sort of real-time data analysis, working with Kafka and Spark streaming as well. And the third type will be BI engineering or data engineering, but they focus more on building data pipelines, doing business intelligence. And there's also the ML data engineers who sort of help or support data scientists to automate data science workflow, doing ML ops stuff as well. In some companies, I've worked with people who are data engineers who does a lot of machine learning, pipeline building. So I guess the job title doesn't really matter. It's like what you do. So I would categorize them into ML engineer, but it could be a data engineering title. So these are different types of data engineering jobs. It can be, I think it can, there will be more types, but this is why learning data engineering can be challenging. Like, what should be the focus? So I'm happy to talk about the curriculum. Eric, our program manager, has designed because we've run this data engineering program a couple of times, and based on industry feedback and also feedback from the students. Right now we're on version 4, which means we're launching the 4th cohort, and it already looked very different from the first version. I think in our first version, we were teaching like GCP, Hadoop, a lot of the big data stuff, but and now we're actually focusing more on the modern data engineering stack. So we're introducing like DBT, Snowflake, and how to build data pipelines using Airflow. Anyways, I'm happy to discuss that later in my presentation today. Okay. All right, so let's talk about the job market before we talk about WeCloudData's data engineering bootcamp. So first of all, I would say data engineering is very, I think working as a data engineer is pretty cool, especially nowadays. If you consider people who work as data warehouse engineers or ETL engineers, they usually are in the IT department. And data scientists is usually in the business, department under like the chief operating officer. So it feels very different, very different environment. What I'm happy to see nowadays is that data engineers, a lot of times they work in very close to the business teams, and a lot of data engineers actually work in the data science team, or companies are starting to have a chief data officer, and then under the CDO there will be data engineers, data scientists, there will be BI analysts as well, which I think is really cool, because the impact of data engineers work are definitely becoming more and more becoming bigger and bigger, because in my view, I used to work as a data scientist, but I did a lot of data engineering work. I started to appreciate the importance of data engineering. I think that was many years ago when we worked on a project that requires running Hadoop jobs, and that was way back 2012. That's 10 years ago. So we're building pipelines, and as data scientists, we actually had to pick up like, Java programming and write MapReduce jobs in order to solve that very specific data problems we're trying to solve, which is personalized recommendation based on graph data. And so we did a little bit hacking, definitely not, great software engineers, but we get it to work. And someone did some similar work at Oracle, and it was, it took them like 20 hours to run the job. In our job, like it's very different data set we're using. Just as a benchmark, the entire MapReduce job took like about 20 hours to run, and it was actually a software engineer who helped us, optimize our code, and it got, it took, I think after the first try, it took about 5 hours instead of 20 hours. And later on, they also helped us, to further optimize the code, the MapReduce code, and eventually run a lot faster. So at that point, it struck me, and I started to appreciate, how important data engineering and coding is. But it's a different environment now because tools are getting more and more powerful. So we don't really need to write a lot of low-level programs like, Java MapReduce code. Apache Spark in general is way better experience. And with Spark, 3.0, it did a lot of optimization. So data scientists can even work with, data frames in Apache Spark. And a lot of the optimization has been taken care of by the tools, right? So the tooling are a lot better than before. But still, I think data engineers will be able to help data scientists, optimizing data pipelines. Because when you run one data pipeline, if it takes like, 30 minutes, it feels okay, right? And, you can definitely, have the patience to wait. And most of the time, these are nightly jobs. But the company will start to need data engineers when they have a lot of data pipelines, right? Some of the companies that we worked with, at least on the training side, they have 5,000 and even more data pipelines, right? So the big tech companies will have tens of, even hundreds of thousands of pipelines running every day. So if every single job is going to take half an hour to run, imagine how much resource that's going to be required to run all of those jobs, and they're all running in the cloud. So the bill is going to be crazy. So any kind of optimization is not only helping the data engineers to become more productive, it's also helping the companies saving a ton of money. We're talking about millions of dollars, right? So that's where the data engineers come in and help, help make everything more efficient. So I'm hoping that, in the near future, everyone in the businesses are starting to appreciate data engineers just like they appreciate data scientists. Anyways, data engineers are very cool. And I think job satisfaction is great because the job demand is really good right now. Compensation is very competitive. And I think especially, right now and in the next, in the next few years, this field is changing and evolving really fast. So data engineers sort of wanted to keep learning. If you worked with some traditional technology stack, now you're moving to open source, working with different kind of tools, company moving to the cloud. So in the past, you might be running data pipelines, running on an EC2 instance, but now you can consider using Docker containers deployed to Kubernetes. You can work with Apache Airflow. So there are many different options. A lot of these tools can get the work done. Working as an experienced data engineers, you sort of have seen many kind of problems already. So you know what the best tool to use to solve specific problem while keeping the bigger goal in mind, because you also don't want to create, a lot of technology debt for the company. So there are a lot of optimization you can do actually. So I think data engineers a lot of times need to work as a data architect, need to understand a lot of different platforms will definitely help you as well. The job is definitely challenging and there will be a lot of things you can learn. And data engineers having big impact. They help eliminate a lot of the repetitive work. They can help make everyone else's work less painful and more productive. I wholeheartedly believe in this, and that's why we decided to launch the data engineering program. And again, data jobs in general, AI data is definitely a growing field, because we just keep collecting more and more data, and the data is exploding, and especially with Internet of Things, and a lot of companies, even government of Canada, is considering data as a new asset, right? Or data is the new oil. So that means the governments are going to push data and AI. It can only generate more data on a daily basis.